Hello everyone, how are you all? Welcome back to the Phones Medic Education. I hope all are you good. In last video, lesson 2 in network section, we discuss about 4GPA, 4G amplifier, voltage requirements, right? RFFE protocol, how 4GPA working, how to test 4GPA. I mean testing the 4GPA. Alright. Along with that, we discuss about WTR IC, our transceiver IC, voltage requirements. How 1.8 line work, how 1.0 line work, or you can say connector 3 different boards, how to track, what are the ground line importance, how all these requirements of the WTR IC, how to check each and every detail in lesson 2. Now in lesson 3, today we discuss about controlling section of WTR IC, right? Also the crystal, importance of crystal IC, or you can say crystal component. What is the crystal? All about crystal, frequency, also difference between SDR and WTR. Little bit information I will give you about SDR IC. After that APT and DRX IC. So start the video. Hope you like this video and watch it. Now let's start the topic. So first we open the layout and find the WTR. Now you will see U3000. Just copy this and paste in schematics. Right. Now in last session, this is a controlling panel of WTR. Right. Now in last video, or you can say last session on a network section, we understood how the voltage requirement of the WTR, which are the voltage lines connected to the WTR, and how many volts, how to trace voltage line in WTR, how to testing, clear all these lines, how this line works, where are from these lines connected, how to diagnose and how to test all these things on a power ground section on WTR. Now in this lesson we understood controlling section, right? Now you will see pin number 51 called XO, right? XO in. Now this line, follow this line. Now there is another name called WTR XO clock. That means this is a crystal clock for the WTR. WTR IC is our transceiver IC. So this line for clock signal for the transceiver IC, right? In this line you will see a capacitor in a series, also a resistance, right? Now in this capacitor, also the resistance. A capacitor in a series, because capacitor passes the frequency well, because there is a clock signal, right? So capacitor passes the clock signal well. That's why capacitor uses also the noise clearation. Now if any one of these, both of these components damage or open, this line does not work. It means clock signal not received by the transceiver IC, right? Means transceiver IC, this signals not connected to the transceiver IC if any of these component damage or open. So your RFIC does not work because the requirement of RFIC, your transceiver IC not fulfill. Clear? For that you must check these components, right? How do you check? I will tell you, right? Now just click this line, and this line come from, you will see WTR XO clock. Now this line come from which IC? Power IC PM8937, right? In this line you will get a clock signal, that means a frequency signal. Now why the WTR IC or your transceiver IC need clock signal, and how this clock signal work, or right. So let's discuss about this. Now, because this is a clock signal, so you can measure only with the oscilloscope, means DSO, because this is a oscillation signal. In this signal, you will see this like a wave shape, right? That's why only measure with the DSO or oscilloscope. I'm already told you, if this signal did not connect the WTR IC or transceiver IC, your IC does not work, right? Now let's discuss about how this frequency generate by power IC. Clear? Now you will see a crystal in your mobile phones like this. I will show you first. There is a motherboard. You will see near the power IC this crystal. This is called a crystal, right? You can check any motherboard near the power IC. You will see these type of the component called crystal or EXO. How this work, I will tell you. Also called quasi resonator. Now, before we discuss this, I will give you an example. Now, those people who repaired a Samsung keypad phones, right? When a phone come to you in a network problem, a Samsung keypad phone basically, or no service, right? When you open the phone, most of the technician do first thing when open the phone, separate the motherboard. After, they will heat through SMD this component called crystal. If this trick does not work, they replace this crystal with the another motherboard, right? Or sometime you change the direction from this to this. Change the direction and fix it in motherboard. After you see your phone network problem resolved or no service issue fixed, network came back, you can all, after that you can make a call. So basically a network problem resolved. What happened when you heat up this component or replace it or change the direction? Your network came back, because through this signal, through this component, power IC create clock signals. Or you can say, if this component dry solder, due to this problem, no service issue or network issue create. How? I will tell you. How this crystal work. First of all, in mobile phones, you will see 19 megahertz, right? Also 26 megahertz, 32 megahertz, these type of crystal. Now megahertz is a unit, because this crystal output, or you can say this crystal generate frequency. That's why it's measured on a megahertz, hertz, right? So you can only measure with the DSO, right? Now, this crystal also uses in the digital devices, electronic digital devices like your clock, quasi resonator, right? Also in your laptops, right? Also already know motherboards, also other digital devices, or you can say other digital motherboards where that data line works. So the clock signal needed. Now in another example, you will see these type of crystal called RTC in a Nokia motherboard, Nokia keypad motherboard. This crystal called RTC, real time clock. The uses for the maintaining the clock signal in your phone, because the keypad phone with a removable battery, for this RTC uses for the maintaining the time and date. Also the help with the power IC on a boot sequence in latest phones. So power IC know how to emerge, or you can say how to produce first voltage, come after second, come after third. right? Basically a timing sequence. Got that? Now, how this work, I will tell you. First, I will show you a diagram so you can better understand. Now, in front of you, there is a diagram, right? In this diagram, you will see power IC, CPU, RFIC, or a exo crystal. You will find the crystal near the power IC. Check your motherboards. If you are available in your desk, check the motherboards. You will find it near the power IC. Now, how this crystal work? Let's discuss. A 1.8 voltage through power IC goes to the crystal, right? 1.8 voltage. After this, the crystal formed a AC wave shape. It means DC to AC on a wave shape. Convert this. This converted the frequency, right? And goes back to the this frequency goes back to the power IC, right? This is called clock signal. I will explain to you. The power IC, give it to the 1.8 voltage. Now crystal convert this voltage to the frequency. How? Crystal made with the two elements. When power IC get the DC voltage to the crystal vibrate itself internally. After it produce a clock signal according to the value is on. Suppose it's 19 megahertz. So it's vibrate and produce a clock signal or stable clock signal, right? If this clock signal not generate, or you can say this crystal does not work, your phone become a dead. Why? I will tell you. In previous videos or in mobile phones, you will also hear mobile phone in a protocols like SPMI protocol, I2C, I2S, these type of protocols. Through these type of protocols, your CPU control the all slave IC, even your power IC, your power controller, also the other slave IC like your RF, in your network section 4G IC, 2G IC, RFFE protocols, or another sections like your display IC, graphic IC, your charging IC, all other ICs in your phone called slave IC, or your CPU, the master IC. So CPU control the all other ICs through the protocol, whichever protocol used by the phone, right? It means the data clock signal. Clear? Now, how the CPU create or communicate this data clock? That is, I will tell you. Now, exo signal crystal form this clock signal and give it to the power IC. After the power IC generate many signals. First signal called BB clock, baseband clock for the CPU, right? Another signal called RTC for the CPU, right? If this BB clock signal does not work, your CPU does not activate, right? Your GPIO section, right? So your phone become a dead condition. If this line does not create, your power IC does not work or activate, right? Also, if the RTC clock is also important, I'm already told you. Now, power IC also generate the other clock signals, one for RFIC, your trans receiver IC. Already we see the schematic called EXO in a WTR. Just we discuss about this line. So this signal from power IC. That is how power IC generate this signal called clock signal. Hope you get it. Also power IC create another clock signal and give it to the audio IC, also the Wi-Fi Bluetooth IC. I hope you get my point. After this CPU, these signals, CPU generate the protocols lines. Hope you get my point, right? I hope you can understand these things. If you want more information about this crystal, tell me the comment, because this is a long topic. So it will not make in one video. So I will make another separate video on a crystal, right? Because in this video, we also need to understand other ICs work. So if you do not understand, or if you want to know more about crystal working, then tell me in a comment. I will make a separate video. Also, I am trying to explain you whatever topic in previous video, also in this video. I am explaining in a normal language, or you can say basic language, so that even a fresher student who does not know about the motherboard circuits in a mobile phone or basic electronics, he also can understand these things easily. That's why I'm using a basic language. Otherwise, if I'm using the technical language, the technical big words, so you can't understand most of the topic, right? You get impressed by me if I'm using the big technical words. You will think sir had a great knowledge in a technical basics, but you can't understand the main topic, how these things work. That's why I'm using the technical words on a convert to basic language, so everyone understand easily. Because I'm not here to impress you, I'm here to teach you, right? I'm here to teach you as like this you will work on your table. I hope you get my point. That is why I am teaching like a basic language, not in a technical language, in a technical big words, heavy words, right? I hope you like my teaching, which way I'm trying to express you in my words. So if you like my teaching, one comment or one like if you want, right? Get back to the topic. That's clear. I hope you get all these things, right? Now get back to the schematics. Now this power IC PM8937, this produce the clock signal to the RFIC. Now how? I will show you. Now you will see pin number 3 and 2, in and out, XTL 19 megahertz in, XTL means crystal, and out. You will see this X0701. This is a crystal. This was a crystal sign like this, right? You will see our second pin ground, fourth pin NC, one pin is a connected to the inside and third pin connected to the outside. Through one pin it's get 1.8 voltage, and third pin it's produce the clock signal, right? Sorry, from the third pin, right, it's get input, and from the first pin it's give it to the power IC output. Clear? Now let me show you where is this. Just copy it and paste in layout. Now you will see near the power IC, right? this. Same, near the power IC, you will see this. There is a two capacitors. There is a two capacitor, 1 and C. Right? Now, look at this. I've already told you the BB clock. You will see a BB clock with a 0 ohm resistance. Through this line, power IC get a signal to the CPU, give it the frequency. If this resistance open, then your phone become a dead. Right? Now click this. Now this signal goes to the U1101. Right? Now where is this U1101? In layout, zoom out, you will see U1101, a CPU. I hope you get my point. Now get back to the schematic and you will see this signal. Again, copy, and you will see, I will show you another enable signal from this. When CPU receives this signal, CPU get back to the enable signal to the power IC. MSM BB clock enable this signal directly to the power IC. There is a no component in between it. Right? You will see MSM block enable, XO enable through CPU. Right? I hope you get my point. How crystal work. Right? Now let's get back to the WTR IC. For this, click this, and now get back to the power IC, and through this line, now we get back to the controlling section in a WTR IC. Clear? Now next line, 47 and 50 pin ball pin. Right? RFFE clock and RFFE data, radio frequency clock and radio frequency data. In previous lessons 1 and 2, I am already told you radio frequency RFF, radio frequency front to end, how this protocol work in a network section. Right? Now something is difference. That is why I will tell you again. Now click this line. Now this line connected directly to the GPIO section. Right? Your master CPU. Now again click this line. Now you will see this line get back to the your controlling section in a WTR IC. That means this line connected to the CPU direct. In this line you will see two capacitors. Right? Or you can see there is a NF. NF means not fitted. That means this capacitor, both of capacitor is not available. Right? NF means not, NF means not fitted. So this two lines directly without any component connect to the CPU. Right? Through CPU, through this line, CPU control the WTR IC or communicate the WTR IC. The clock signal is the difference. This for the frequency through power IC, a clock. These two protocol working for the CPU, or you can say communication lines. In previous video, we see RFFE clock attached with the 2GPA and 4GPA. I will tell you. Now suppose there is a CPU. Right? Now 2GPA, 4GPA and your WTR IC. So RF, CPU, 2G and 4GPA. So CPU through those two lines, clock and data, RFFE lines connected to the 2GPA, Also the same line connected to the 4G PA, right? Even if there is another IC called APT, right? This line also same connected to the APT IC, right? That means this protocol working many multiple ICs, right? But for the your transceiver IC, this communicate different lines directly to the CPU. Now, if any one of this IC does not work or not connected properly to the CPU or not communicate with the CPU, no service create. Also, if this RFFE line not communicate with the WTR IC, also same the no service problem create. But the difference is these three communications line working difference from the transceiver IC. You will see some component in it. I will show you in a resistance, right? Suppose this 4G PA data clock does not, for any reason, it's break there, right? So you can jumper it from this data to data, clock to clock. But if this line damage directly to the internally to the CPU, you can't make the jumper from these lines. You can open the CPU, right? Also, if you check these lines, you can check this is a pin IC, check on the pin directly to your pin attached on your multimeter needle, right? But for this RFFE clock, you will open the RFIC. After that, you will see a pads on a motherboard. So you can check the diode value, whether is connected these balls. I hope you get my point. If you ever confused or if you do not understand anything, comment me. I will tell you again, or I will say I will give you a reply. I will teach like you a mentor for supporting you every step, right? Hope you get my point. Now get back to the WTR IC. I hope you will understood RFFE difference between these two, right? For which connected to the 2G and 4G line, also other connected to the transceiver IC, and how you can check it, right? Get that? Now these all lines remaining like GP data, BBQ, BB1, these all are frequency line, right? Like DRX, this line connected from the DRX IC, right? Now you will see it transmitting BBIP, BBIM, BBQP, QM. Now I will show you these lines. First, I will draw in a drawing RFFE lines. So you can see these are clock signal. After CPU produce data clock signal to control the WTR IC, these two signals, right? And this signal directly connected to the CPU without any component. So how do you check this signal? I'm already told you. Just open the WTR IC and check the motherboard with a diode mode. Check on the motherboard pads on a diode mode, right? Red probe on a ground and with a black probe. You can measure the value, which pad it connected I will tell you again. Just go to the Borneo on a network section. Now in network hardware solution, you will see there is a no RFFE clock 1.0 line, 1.0 line, and this line 1.8 line. Right now another line. These are, which is this pink line. What is this pink line? Name. Right, WTR TX GSM middle band. So which is this yellow line from RX receiving, right, attached with the band switch, or right. Also the yellowish line WTR TXO. This is also for the band switching. Now there is a no RFFE clock. If you look at the hardware solution, there is a no hardware, or you can say there is a no pin connected to the, or you can say no pin shown to the RFFE signal, which show you will see in the schematics, but there is a no pin, RFFE pin, radio frequency front to end pin. Now in a schematics, this pin connected to the pin number 47 and 45. Now just go to the bitmap. If now suppose this pin, when you open the WTR IC, motherboard look like this. So you can check, suppose these two pins, right, on a RFFE pin, suppose. So you can, how to measure red probe on a ground, right, with a black probe you can check, or you can say measure the diode value on this point. If you get a diode value, that means this line connected to the CPU. Your problem in a WTR IC, replace the WTR. If you do not get value here, diode value on RFFE point, that means you must open the CPU like this. Under the CPU, where this ball connects, or you can say where this line coming, you can make a micro jumper from this to this point. After put back CPU and WTR IC, right? Now this is the beginning of the network section. I will tell you, I'm not saying this was the complete tutorial of the network section. Network section is a very long section, you can say. There is a multiple problems. Why the WTR IC do not any voltages? Why the voltage fluctuations? So it's a multiple problems. I will give you all information slowly or step by step, so you can basically understand each and everything, right? Or you can understand each and every concept. If I'm giving you a top video or premium video, you can say, which had a major faults, or I'm not giving you basic information, so you could not understand, right? I hope you get my point. Also, this is not the basic, this is the middle one. Not as like you will get a higher or advanced level tutorial, or nothing is like a basic tutorial. It's a middle one, you can easy to understand. After that, whenever next network section tutorials, or when I'm giving you practical videos on a live motherboard, so you can understood how I'm working, right? So you can watch properly each and every video, because after this sessions I'm working on a next project which I'm delivered to you live repair in my desk, diagnose phones. There is some delay because I'm short of some cameras, because there is a need multiple cameras. For this I'm showing you my multimeter, which are the readings, also my DC power supply, also my iSense charger, right? You can see everything, which point I'm check or measure, which line I'm told you. So multiple camera needs, I think that is why it's delay, right? So wait for these type of videos. Now back to the schematics. Now I hope you get my point, and also you will understood XO line, RFFE clock line. Also now these transmitting BB, IP, baseband IP, baseband IM, QP, and these are data lines, right? Also if these lines are damaged, right, your IC does not work. Now this line coming from the GPIO section, it means the CPU, right? How to check? Now click this line, follow this line, you will see this line, you will see some capacitor, right? If this capacitor short, this line is short, so your IC does not work. Now you will see first U1101, this is a CPU network section in a CPU. Now you will see there is a also look like writing on a resistance, also the showing a icon of a coil. So there is some misunderstanding in this concept. So if you see whatever here it is a coil or resistance, for this just copy this and paste in layout. Now next you will see this is a resistance 1401. Now in a component section, where is this? Near the CPU. In this section you will see a coil. So there is a confusing somehow. So now in your experience, how can you check this line? If this coil open, the CPU can't connect to the WTR IC. So you can check both of the ways in this coil. Just open this coil and check this side. If you had a diode value, that means this line connected to the CPU. If you will see this side connected to this diode value, this side, you will see this line, this coil is a proper connected. So also when you open the RFIC, you will check on these point also 22 pin, 18, 17, 15. How? One probe on a coil or input side where the CPU connect, and other side connected to the 22 pin wall on a continuity mode, beep mode. If you had a beep or a 00, that means this line connected. You will see a rarely problem in these things, in these lines, or you will see in these lines, this from DRXIC, right? All these lines, these are data lines. I'm already told you these lines had a rarely problem. If your phone accept is it not a drop down case or water logging, otherwise you will see rarely, and this line had a problem. Most of the problem in voltages line or WTR, most of the time you will see a fault in a WTR. You replace the WTR, you will see your phone get working back, your problem fixed. So I will tell you all about WTR IC, how basic things work, how to routine checkup in a WTR IC. Now let's go to the little bit information of the SDR IC.